In this tutorial, we're going to look at a few things we can do with n-dynamic objects in Maya. In this case, we're going to make these particles stick to the surface of this little flagellated bacterium. So we just play through here. See, it's going through this field of particles that are being emitted by the surface, and some of them are sticking to the surface here. So what are we going to look at here? Well, we're going to take a look first at how to create these particles. In this case, they're being emitted by this surface. We're going to look at how we control their size, speed, number, and so on. And then we will look at how we create an object like this, which is a non-deformable dynamic object. It's a passive collider, or in here you'll see it referred to as an n-rigid. And then just as a bonus, we're going to add some hair onto the surface that will react to the motion of this object. And they also interact with the particles too, although that's not too obvious. So why don't we rebuild this scene and see how we do these things. Okay, so we'll just start by creating a plane. And I'll freeze its transformations and delete its history. And just turn off my grid here. And we'll have it emit particles. So under the N particles menu, you'll see there's lots of ways to create particles here. We're going to focus on this one that says emit from object. But it's important to, first of all, have the object selected, then open up the options, because by default, the emitter type will be omni, even though you chose that you want it to emit from the surface. I'm not sure if this is a bug, but we just have to go in and change this to surface. Now, one thing you can turn on here, but we don't need it. We'll look at this in another tutorial, but we can say need parent UVs. It says it only works for NURBS, but it works for polygons too. And what this does is record the position on the object that these things were born and the UV coordinates. And this can be useful in other applications. For now, we don't need it, so I'll just leave it turned off. We'll keep the speed at 1 and the normal speed at 1. So that's just, it means they're traveling up the normals. And we'll just say create. And if I play the animation, the particles will just start falling. Because when you create any kind of end object, it creates a nucleus node, which has gravity built in. So we can turn the gravity off if we want to avoid the particles falling. Or we can go into the end particle shape node, and under dynamic properties, here it is, we can tell it to ignore solver gravity. And now you can see that they're moving up. They're a little difficult to see, so I'm just going to select them. And in the particle shape node, if you want to change the type of particle, that is under shading, and we'll change it from points to spheres. And if we want to change the particle size up at the top, we've got particle size here, so we can make them bigger or smaller. And if we want to randomize that size, we have radius scale just below it here, and we can change this ramp here, going from 1 to 0, and set the radius scale input to randomize ID. So we'll just randomize them based on each particle ID. Each particle has a number, and so it can randomly apply any effect to each particle separately. So this this radius scale, whenever you see scale, that means it's a multiplier. So it's a multiplier of the radius value. So let's change that to 0.2 to get something like this. Now, if we want to change the number of particles that are created, we can see in the particle shape node, it tells us the count. There are 391 so far, but it's in gray. That means it's controlled elsewhere. And if we just twirl down under the polygon plane, there's the emitter that we created before, and we can change the rate, which is set to particles per second. So if I change it to 300, and play back, you can see we can get more particles. Okay. So the particles are just moving at a constant rate now, if we look at it from the side. They do slow down, they lose some of their energy here. If we want to accentuate this, we can go into the particle node, the particle shape node, and under dynamic properties, we've got conserve. If we change this to a lower value like 0.95 rather than 1, it means it'll lose 5% of their energy, I think, per second. Right, so you can see they're losing a lot of their energy quickly. We can change this to 0.99. So it just loses 1% of their energy. But over time, they will lose all of their energy and just stop. So it kind of depends on what we want to do here. For now, I'll just let them kind of fly, keep going. And right now, these particles are set to live forever. If we wanted to change that up at the top, we can go to lifespan. They're set to live forever. We can change it to constant, and let's say change it to 2 seconds. Then as we play, you can see after 2 seconds, they start to disappear. So you can do something like that. Let's say you wanted to do that and have them sort of fade away. You could either make them get smaller over time, or we could control their opacity, which is down here under shading. So opacity scale, if we change this to 0 and set the input to age, we can just have them kind of fade out as they get to the date of their death, which is 2 seconds. And let's just make it a little more obvious by making it a little longer. So you can see they kind of fade away. So you can do that if you want. I'm just going to get rid of that. You can also do it with radius, but we're already using radius for randomized ID. But if we change this to age, then they're born big and then they fade away by getting smaller. We could reverse this by having them born small and then they get bigger. And then they come to the end of their lifespan. What if we want them to, maybe we want them to get bigger and then towards the end get smaller. Can do that too. So they just kind of wink out like that. So there are different things we can do here. For the purposes of this, I want them to just live forever. So I don't want them to disappear once they get stuck to our object. So I'll just change this to live forever. The other options are random range, which is like constant, but then you can set a value around the lifespan. So if I set this to 1, some particles will live as little as 1 second, some will live as long as 3 seconds. So let's set it to live forever. Oh, and I'll randomize their size again. Just to add some variety. Okay, so far so good. So now, if we want to have something go through this field of particles and have these particles stick to them, we'll have to create an object first. So let's just make a simple shape. I'll make it sort of a cigar shape here. Wrong way. Something like this. Make it a bit bigger. Select these. Just using my soft selection. Scale it up. Scale these ends down a little bit. And it'll look like this. So let's just smooth it. So shift right click, smooth. Okay. And then we'll just freeze its transformations, delete its history. Okay, let's not worry about the... Should we do the hairs first? Yeah, let's do the hairs. Actually, no, let's just leave the hairs out for now. And I'll just move it over here. I'm going to turn this into endCloth create passive collider. So if you want to make an object work, a surface work as a dynamic object, you have two options. You create an endCloth where it becomes a deformable object, and passive collider, which means it just collides with things, but it doesn't deform or react to things like gravity, force fields, etc. So I can just create a passive collider. So if we play the animation now, I didn't animate it yet. So if I select this and set a key on its translate X, and over my 200 frames, just have it move through here, set a key, and we'll play the animation. And you should see, yeah, it's hitting those particles and pushing them out of the way. Okay, so far so good, but we don't really want it to push the particles out of the way. We want them to stick to the surface. So how can we do that? We can select the end rigid object and go into the shape node here, end rigid shape 1. And we can just make it sticky and see if that does the trick. So far so okay. Let's see that again and see it at the end. So they are sticking to the surface, but when it stops, some of them kind of fly off. So we could make it extra sticky. Set that to a higher value than the default in the slider. See if that solves our problem. Not quite. I think some of these ones are being just pushed along by the other particles and not sticking to the surface. So, it's introducing some problems here. Let's actually make this twist as it goes through, just so we can get more of the surface covered. So I'm going to go to rotate X, set a key, then over this time have it rotate 360 degrees, set a key, see how that looks. So we can pick up a few more particles along the way. It's still getting the same problem. Okay, so what else can we do? Well, we can make the particles themselves sticky. So in the particle shape node, it also has a stickiness factor. Let's just turn that up to 2. So this will make the particles not only stick to the object, but stick to each other too. Still getting the same problem where it's just pushing them out of the way. Let's just get a few more frames in here. So one thing we could try to fix that is to go into the particle shape and turn up drag a little bit, or damp. Let's try damp. If I turn that all the way up to 1, what will that do? Well, it prevents them from moving up. So that's not so good. So that was at a 0 value, so we can go back to 0. Drag, let's turn that up to 0.5. That will also prevent them from moving up too much. Yep, it's a lot. Let's go to 0.1. So they're moving up. Is it going to touch any of them? I don't think so. Nope, so they've got to be able to move a little bit more than that. And so you'll see this is the thing you have to do with dynamic systems. You have to experiment with the settings. You're controlling everything indirectly here. Okay, so that's not quite working for us. We can turn up the drag, but then maybe turn up the speed on the emitter just to get them moving up a little faster. Okay, so it should work. Okay, so now they're sticking to the surface and they're not well, they're flying off a little bit, but not so much they lose their energy quickly, but it's a little weird. You know, to be honest, it depends on what your scene looks like. This thing might just exit the scene and you wouldn't see any of this weirdness. But there's probably a better way. So let's look at something else we can add here. If we go into the end rigid object, you'll see there's a force field generation setting down here. And we can turn the force field on along the normals of the surface. And by default, it's set to 1. And this will push them away, push the particles away, which is counter to what we want. So you can see it's going through and it's pushing the particles away before they have a chance to stick. But if we change this value to -1, then it will attract the particles. Right, so that's already working better. We can see as it goes through the field more sticking to the surface because it is attracting them as it goes through. And the damp is also preventing them from moving away. But I don't think we need the damp anymore because, or even the stickiness of the particles. So let's turn off the stickiness of the particles. And sorry, not the damp, the drag. Let's turn down the drag to its default value, because I think this force field will do enough to attract them to the surface, and then the stickiness of the shape should hold them in place. Pretty good. Some of them are just getting pushed. Well, there's one straggler that got out of the way there, but otherwise it's working pretty well. Okay. Just one other thing. Let's say we wanted the particles to start already like this. We could select the particles and go to Fields and Solvers, Initial State, Set for Selected. So I selected at a point in the timeline where I want it to start like that. And now if I go back to 0, then it starts already. Well, actually starts with them kind of pushed out like that too. So there'll just be far more for it to interact with. Right, so we get lots of particles coating the surface. Okay, so far so good. But what if we want to add hair to this object? So this is a bit of an aside. I'm going to save this scene. And if we want to put hairs on the surface, we can just select a few faces and then have hairs assigned there. But there's nothing we can do. We can go to the Select menu, and then there's this Use Constraints option. And I'll just reset this. Okay, that doesn't work. But down here, there's this random. If we activate random and tell it to act on the next selection, we can say, even if we're going to select all the faces, only include 20% of them in the selection, right? So we just get 20% of all the faces selected here. Okay, so we can do something like that. Now we just have a small number of faces selected. And if we go to N-Hair, Create Hair, open up the options, just reset the settings. So a few things we want to change here. We don't want paint effects. We're just going to output NURBS curves. We don't want it as a grid. We want it to be the hairs to be placed at selected surface points. We want them to be dynamic, points per hair. I'll leave it at 10, and the length 5 is very long, so let's change it to 2. Create hairs, so it's a little hard to see. Let me change the background. Maybe that's a bit easier so you can see the hairs there. And let's see what happens. Okay, well, first of all, the hairs just fall down because they're paying attention to gravity. So we can select the hair system shape. There's a bunch of things that get created here, but most of the work you're going to do is in the hair system shape. And if we go in here, we can, under its dynamic properties, just like before, tell it to ignore solver gravity. But you might notice something else happening here. That force field is also pulling the hairs in. So that's a bit of a problem, right? Because you might want to have these hairs on the surface, but not have them attracted by that force field. Unfortunately, as far as I know, there's no way to avoid that happening. I'm going to go into the hair system, and there's a turbulence setting here too. So I'm going to turn that up a little bit just to make these hairs move around a little bit. You can see they're getting sucked to the surface. They're also being pushed down because of the force of the forward motion of this. But it's a bit of a problem. So what we're going to do is look at another solution. So in the end rigid object, instead of using the force field along normal, we're just going to turn that off. And now if we just play the animation, so those things are being pushed down, and then they're getting stuck to the surface because of the stickiness, which is set to 5, stickiness of the end rigid object. So I'm going to set that to 0. And so you can see, it's kind of hard to see, but they bounced back a little bit now, so they're not all stuck to the surface. You can see some of the hairs here. Right, so you can see the hairs are still moving around a little bit here. They are bumping into the particles. So if we don't want them to bump into the particles, we can go into the hair system shape, and under collisions, just turn off collide. There are other ways to achieve that too, but for now, we'll just leave it like that. But now you can see the hairs are freely moving around. Sorry. Having a bit of Maya trouble here. So we'll just select a couple of these hairs. We'll play the animation so we can maybe see them a little more clearly at the end. Right, so they're still sticking up and moving around. So we can do something like that. But now we've lost the stickiness, right? Of the particles, and we can't use that force field. So what can we do? Well, one thing we could do, I suppose, is just go into the particles themselves and make them sticky. And since they're not colliding with the hairs, they might just stick to the surface of the bacterium here. It's kind of unfortunate that I've got these particles right here. Let me change the animation a little bit, so over time maybe it doesn't end up in this little hollow that I made. So let's just get it to this point. We'll set a key on translate Y, and then maybe just have it ease up a little bit just to get it out of the way. Right, so that's working okay. It's pushing some of the particles away though. So we're going to add one more effect here. So instead of using the built-in force field, we're going to add a different force field to our scene. So we're going to select the particles and go to fields and solvers and select a radial field. And let's just leave it at the default settings. Create that. And so what a radial field will do is push particles away by default. And it's right in the middle of our scene here. So if we play the animation, you can see it's just pushing the particles away, which is not the effect we want. We can go into the radial field though and change some of the attributes. So the magnitude, instead of 5, let's just change it to -5 and see what happens. Right, so all the particles get sucked in towards it and go beyond it. We can change the max distance, which is 20 right now. If we just change it to 2, then it can only reach out 2 units. So you can kind of see in here that some particles in the middle are being attracted to it. But what we want to do is select this radial field and then shift select the N rigid object. And under the fields and solvers, we just have to choose use selected as source. So this shape will now be the source of the radial field. This is still called polycube, and the radial field is a child of it now. So it will be emitting the radial field. So as it goes through, it will pull these particles towards it. And it will still be pulling them in, and it will keep them locked to the surface. And because I only had the particles selected when I made the radial field, the hair isn't influenced by the radial field. Just as an aside, if we go into the Windows menu, Relationship Editors, Dynamic Relationships, and I select that field, if I select the particles, it shows the field here highlighted, which means it's actively attached to it. If I go into the hair system, it shows the radial field, but it's not highlighted. If I wanted it to influence the hair system, I can just click on it to highlight it, and it will now influence the hairs on the surface. I don't know how noticeable it will be. Probably just pull them into the surface. Kind of hard to tell because there's turbulence going on too. But you can turn dynamic field relationships on and off that way. So we can just go into that radial field and we can turn up the value, something like -20, maybe turn up the max distance to 3. You kind of see here that a lot more particles are being attracted to the surface and then sticking there. So I think this is probably the most control you'll have over something like this. It's a combination of making the surface sticky. It's not sticky right now. The particles are just being attracted and held there. I think the particles are still sticky. Let's see if it works without the particles being sticky. It's sort of working, but you can see that they're being attracted to the surface and then kind of crawling over it. So it looks like stickiness is important here. So we can either turn it up in the object or in the particles, or maybe both. Having the object sticky might make the hairs stick to it inadvertently. It works well with the particles, but you can see that the hairs might be getting stuck to the surface. So let's turn down the stickiness on the object, turn up the stickiness on the particles. And so it seems to work well with the particles being sticky. We're getting lots stuck to the surface here. And there you go. So there are lots of different ways to do any of these things, but you just have to problem solve as you go along and find the optimal solution for the particular case that you're working with. So I hope you find this useful and are able to apply to different scenarios. Thank you.